thanks to everyone who contributed to that release. Comes with actually quite a few new features like support for HDFS, the ability to make modifications to schemas and actually commit them, and that sort of thing. So really great to see all that support coming along. Thanks to everyone who contributed there. The next one, it looks like the Rust implementation has been moving along quite smoothly. We've already got the FileIO implementation in, and we're steadily working on the catalog stuff. So great to see progress on both of those different implementations. Back on the Java side, there was also quite a bit of good stuff happening. So first of all, thanks to Anton for a couple of things. We added distributed planning in Spark 3.4, and I'm assuming Spark 3.5. And that basically says if you have this is in Spark, if you have the ability to parallelize and you have basically a lot of metadata files, it'll parallelize planning by submitting a Spark job to scan all the manifest files. So that, I think, helps quite a bit in certain situations where you want your queries that need to go through a bunch of metadata to operate faster. So thanks, Anton, for that. And then there's also the 3.5 support. And that was a fast follow-on from the actual Spark release, because I think the release has been out less than a week. But it's really great to have Spark 3.5 support in. 3.5 support adds quite a few niceties that we're also trying to take advantage of. I think the initial support delegates basically all of the merge, all of the row-level commands to Spark. Is that correct? Yeah, and so it's really great to drop all of that code. It makes it easier for us to actually go and do releases on top of new Spark versions, and also just good to have those things maintained in Spark. So thanks, Anton, and basically the broader Apple team for helping us get all of the merge plans from Iceberg into Spark itself. Next up, I want to say thanks to ConeyLiu, who has been tirelessly working on function pushdown. So the V2 filters in Spark have the ability to push down functions, and we've gotten to the point where we can actually push down Iceberg functions that are used in Spark. So if you say like select from table where bucket of some column equals 5, you can actually go and push that down so that Iceberg selects a particular bucket, or you can also use the other partition functions as well, and we'll push those down to partition filters. We've been waiting for that for a really long time, so it's great to have it. I think we're still waiting on some niceties. So it is possible to push down casts. So I think what we'll want to do is eventually get to the point where we can push down operations like cast timestamp as date equals some date. That's going to be a really nice thing, but we're tracking towards that. Also, I wanted to highlight the work that's being done by Gidon. We got the AES GCM encryption and decryption streams committed in the last few weeks, which means we're tracking right along for metadata encryption. So that effort is actually close to, we've been doing like building blocks, and we're getting close to being able to fully encrypt table metadata in a pretty clean way, with just one table level key that is required to talk to a KMS for. So that's going to be a really nice thing. Yes, the rewrite data files pushed down also in, so that's another one thanks to ConeyLiu. Then I wanted to highlight Amogh's work on strict metadata cleanup. So for a long time, we've had this this issue where certain operations would have unexpected exceptions thrown, And in those cases, we may decide that a commit was actually successful when it wasn't and clean up metadata. We've done a lot of work over the years to avoid these situations, but what we ended up doing was adding the ability for a table operations to signal that it wants strict metadata cleanup, which means that it will only clean up data and metadata files if the exception that's thrown is a known exception and is flagged that it supports metadata cleanup. So things like what is it? There are certain exceptions like commit failed exception is an obvious one, but there's also like certain REST exceptions like a 401 or a 403 not authorized, where you know that you can clean up because the commit actually did not occur. So that's one thing I want to talk about a little bit more in the iceberg 1.4 release and see if we want to use that more broadly. We added this to the REST catalog, but we should definitely determine if we want to add that to other catalogs as well. And then lastly, someone just added vectorized reads for merge on read, delete, update, and merge plans, which does anyone want to elaborate on that?
It basically means that we previously supported vectorized reads with delete files, but not in the actual merge jobs because the merge job actually protected the struct for the partition. So we needed the partition tuple to encode a delete, and then basically broke the vectorization. We didn't support such constants in the vectorized paths. Now it's fixed. So you have like vectorized reads also for the merge commands themselves, not just for the previous.
Oh, that's fantastic. I know we also still want to do like vectorized reads for nested data and things like that. It'd be great to see those continue as well. Mm-hmm. All right, so thank you everyone for all the work. It's really great to see the good stuff going in, and I'm pretty excited about getting all of that row level command code out in 3.5. So let's move on to the iceberg 1.4 release. We've actually got quite a bit to talk about here. We have, I know, some pending updates. There are a couple pending Spark updates that have been opened, and I know we're going to review those as soon as possible because ideally we're going to get a release out in the next 10 days. I think that's the deadline to get this into the next EMR release along with Spark 3.5. Are we missing anything else that needs to be opened? The one that came to mind was a PR for advisory partition size.
Yeah, so that's probably the only change that I'm aware of on the Spark site that is really kind of that's probably worth considering. So I'm not sure whether it's a blocker, but I think it is that important that we may actually want to wait for it. It's something that I'm looking into right now, but I think it will have a lot of value because this will allow us to request the shuffle advisory partition size that's different from what's configured in the session. And the session only configures 64 MB of the shuffle data. So when you write this out into like Parquet file, it compresses much better. And then you end up with tiny files. So that has bitten us in the past and kind of degrades the performance unless you do the configuration. And that's the 3.5 specific feature that was supposed to be.
My only call on that is that would just be performance related, so we could put that out in a minor. So I don't know if we want to hold for that.
Yeah.
So yeah, this seems like when we talked about having a table setting that can affect this, which I think would be worth getting in because that should just be a very quick one, and then maybe just returning the target file size by default. I think that's unless our target file size is crazy.
It's 512.
Yeah, that's a bit big.
We actually have been setting it larger because we want if you don't set it larger than that, the compression still brings it down, and you still end up with files way below target file size.
Okay.
Your mileage may vary depending on like what sorts are being invoked inside of Spark, and if they still or not, and whether or not you have enough RAM. But like, that's life in Spark, I guess.
All right. So maybe just setting that by default to target file size and then allowing it to be overridden is a good like thing that we can get out in the next couple days. Does that work?
I'm fine with that too. Sorry, I didn't mean to throw rain on that. I was just saying, let's not hold out for 2 weeks if we have to discuss it or not.
Yeah.
Anton, I'll leave it up to you what you want to get in. But yeah, we probably need to make sure that that's. I'd opt for simpler rather than more complex just to get this out.
Sounds good. Yeah, let's not block it for too long, so like I didn't want to block it or anything. So probably give me tomorrow. If I can come up with something that I think would work and would be like flexible enough, I'll submit that so that we can discuss it. And if not, let's do just something simple and then make sure we kind of wrap it up by the end of this week.
So the quick question on that, we would default to not setting it for anyone. You would have to explicitly set this table parameter, or do we want to default? Because if we do default, switching Spark versions suddenly changes your write behavior.
I think we want to default to target file size.
I think it's kind of a broader discussion on as the problem here is that we're kind of trading the parallelism for the file size, and that's kind of like in some cases you want to have higher write parallelism, in some cases you want to have bigger file sizes, and sometimes bumping the advisory partition size may not actually yield bigger file sizes. You can just harm the parallelism. So it's a little bit tricky. So let us maybe spend offline some time to see if there is like a simple solution, and then we can iterate on top of it.
So I agree that we can iterate towards a simple solution. I think though that if we're going to change behavior, a Spark 3.4 to Spark 3.5 jump is actually a really good time to do it, because you're already expecting behavior across Spark versions to change a little bit. And so this is our opportunity to change the behavior, because once we release this, it would be a behavior change when you upgrade Iceberg without upgrading Spark. And I think that we want to do it the reverse, right? If you upgrade Iceberg, this doesn't affect 3.4, but it does if you upgrade Spark. So that's my argument for like changing the advisory size, just because we know that 64 megabytes is too low.
Full agreement there. So
yeah. Like, and it should be probably 8 times that.
So I think it makes sense to default to preferring bigger file sizes in 3.5. I think it generally makes sense. But maybe we can also do something where it depends on the operation, because we know if it's an append, maybe it's kind of less critical. But if you're doing a row level change on an existing data set, then most likely you actually prefer to keep bigger file sizes, because that would not degrade your table that much. So there are some assumptions we can do. So let's see what we can come up with.
I'm good with that.
If I fell off, just to make it a little more complicated, can we also just have it as a table property and a Spark write option, so that you can throw that into your Spark write option as well?
Yeah, that should be an overridden entry. You should also be able to check parallelism in the files.
Okay, yeah, that sounds good. Okay, moving on. So we have Spark versions 3.1 through 3.5 now. So we have 4 Spark versions, 5 Spark versions, 5 Spark versions. Do we want to continue supporting 5 Spark versions? I mean, it's all working, so it does seem like there's no harm right now to leaving them in. That's just, we're accumulating a lot of Spark versions.
I would argue there is a little bit of harm on like keeping them. Primarily, like there are like a lot of issues. And the first one is that we send in the message that these versions are actively maintained. I think I said that on the dev list before, while we actually like cherry pick some of the changes. And like if, for example, there is a new release of Iceberg right now, and folks like use Spark 3.4 to do some sort of benchmarking of row level operations. That implementation is like 2 years old, right? And it like the results in the implementation that you get is like subpar. But we send in the message that these versions are actually new, maintained, and whatnot. So I think that's the first problem. But it's also kind of hard to maintain all of this. If you change something in core, now you have to modify, in some cases, 5 Spark versions. So it makes the life of the people who maintain it harder. This time, for example, I even had to do something specifically for the dependencies, because the netty buffer dependency that's used in Arrow, I couldn't come up with one dependency that would work across all of the Spark versions. So I had to introduce 2 dependencies and then override that in 3.1 and 3.2, because I couldn't basically just bump it up. So it adds the build complexity, and it also adds the need to support and then test it before they release. So I think it's getting out of hand, this 5 versions a little bit.
It seems like a bit much. This probably isn't something that we should decide here, but let's bring it up on the dev list again. You know, we recently dropped Spark 2.4, and the idea there was if you're using Spark 2.4, you can continue using older versions of the library. And I think that that's a pretty reasonable path forward. And so maybe we want to just keep, you know, 3.3, 3.4, and 3.5. I think there's a good argument for it now. So yeah, let's revisit that, I think, on the dev list. Okay, next one, I wanted to highlight Amogh's work on strict metadata cleanup, and at least put out there that other people may want to change the defaults or their implementations to invoke strict metadata cleanup, particularly in Hive. I know we've had a lot of like weird locking issues and things like that in Hive, and if this goes wrong, because of the way Hive locks, if you lose a lock and it actually has committed, you know, you can delete files and corrupt your tables. So I'm thinking that this is probably a good idea. I don't know if anyone has an opinion about what the default should be here, but it seems like this is probably a good thing to get in.
Could you elaborate on what that is?
So strict cleanup basically says, rather than trying to catch exceptions and then throw them as commit state unknown, we basically assume anything except a standard list of exceptions is commit state unknown. So it basically flips that logic to be strict. So we will only run metadata cleanup, you know, full metadata cleanup, if we get one of the exceptions that signals that we know absolutely it committed or it didn't. Well, I guess in this case it's that it didn't commit, because they're, you know, exceptions that signal failures.
Mm-hmm.
I think it's a bit safer.
I think that's a great idea. I think we originally had something like that, and then we started tightening it up. I can't remember. Back when we originally introduced commit state unknown, we were doing stuff around that.
So commit state unknown is a good solution still for retrying and determining, like, not just giving up, but saying, okay, we need to determine the commit state. So the refresh and logic in Hive is still valid there to just go and check, hey, did this commit actually succeed? At the same time, like, I think that there are still cases that we see where people like end up with corrupted tables because of deleted metadata. So we can turn this on by default across all formats. Right now, it only affects REST. So do we want to do this by default? Do we want to do it in Hive? What are, Dan, I see a nod.
So
by default?
I would strongly encourage turning this on across the board, just because the issues that we've seen, even in community Slack, where people may not have a way to recover from S3, like if they're running on HDFS, if your job deletes metadata, it can put you in a catastrophically bad scenario. And so even though we have narrowed down the number of edge cases where this can actually occur, it still happens randomly. And so I think the best thing is be very strict about when you actually clean up, because worst case scenario, you have to run orphan files and you have to clean up some extra files.
Yeah. All right. Then Amogh, why don't you open a PR and put it against the 1.4 release, and we'll get that done.
Yeah, sure.
Right. The next one is using Zstd by default. I think we are pretty much in agreement on using Zstd by default or updating to Zstd. The concern here is just that this is such a large PR. Let me see.
Is it?
It's mostly test changes where we assert on like the exact file size of things, which we really need to get out of our tests. Got to stop putting in concrete file sizes into stuff.
I think Gidon took care of that. So he rewrote some of those tests that assumed that logic. So I took his PR and rebased it. So it should be fairly straightforward. It's just a couple of places that we modified. The first place is, so the change that we're trying to do is actually only for new tables, right? So the existing tables should be unaffected. But the only two places that are being modified is the place where you create the table metadata object. So now it will actually have like a way for you to store those new defaults. So for example, right now, if you're creating a table and then it's a 1.4 release, then we would actually persist the codec for Parquet because it's a different default. And this will actually apply and stay with the table for its lifetime. In the second place is the rest catalog, because it doesn't create table metadata object. It's on the other place. And that should be it to do that. And the rest is just test changes.
Okay. That seems reasonable to me. I'm not entirely sure about adding it to the REST catalog. I thought we were doing it at the individual catalog level because I saw the REST catalog code. It seems like that might be up to the REST service rather than explicitly setting it. But I'll take a look and we can get that in. Okay. And then the only other blocker, the major blocker, is the Flink credential refresh. And I wanted to bring that up here to see if there are any, if we're ready to go on that or if there are any objections to it. So Stephen, this is the one where we've been adding a way to refresh tables in Flink executors. And this is because they're long running. And when we initialize FileIO, we end up using a credential that expires. And we need to refresh that FileIO to get a new credential every so often.
Yeah, I think I'm actually working with Brian on the code review, so we're close.
Okay. Yeah, if we can get that reviewed again, hopefully, sometime today or tomorrow, that would be really helpful because I think it's about ready to go in, and we definitely want to get that into the release. Okay. Then let's move on to discussion topics.
Actually, before we move on, just so everybody knows, I did create a 1.5 milestone. So if there is anything in the 1.4 milestone that we think we should just like bump to 1.5, feel free to do that. Or if you want to start tagging some items that you'd like to get in for the next release, it's there. I also created a 2.0 milestone because we've had a few issues that have started to come up where there's a significant change to like default behaviors or something like that, where we may want to push that off. And so it's just kind of a holding place for bigger items that we may not want to tackle right in a minor release, but we don't want to lose track of. So just keep that in mind. Feel free to add issues to it.
Okay. Next up, I wanted to briefly bring up the Parquet metrics problem from Trino. So the Trino community found that in some cases they were writing Parquet files where instead of truncating min and max values for row groups, they were large enough to hit this 4K limit and get dropped. And iceberg was basically not detecting that it didn't have those min and max values and was just skipping. So we had incorrect iceberg metadata coming from those files. I think that there's not a ton that we can do about this because if we were to try to detect this, it would basically require skipping, basically no longer using stats for tables, at least for string and binary columns, which doesn't seem like a good idea to ignore all string and binary column stats. So it seems like this is a thing where we want to fix the issue, but it is a fairly narrow problem. It's unclear. We haven't gotten a response on how large, who is affected, or like what causes this problem.
I think we have a little bit of information in the issues that they put up. I believe the scenario is actually when you have multiple row groups. One row group actually has like a min or a max value that is valid. Another row group has one that exceeds the 4 kilobyte threshold for the min max size in Parquet. And so what they do is they just use the min or max value from the first row group, regardless of what happens to be in that second row group.
Right, but we don't know why the stats are not being truncated. So the stats should be by default truncated well below that 4K value. And so we don't know why we're getting stats that trigger this Parquet metadata behavior and how widespread that problem is.
Wouldn't that be a wrong behavior too? Like you wouldn't want the min from the first row group. You would have to say the min is negative infinity or whatever. You can't.
Well, right. So the problem in iceberg is that when this behavior occurs, we're not detecting that a row group doesn't have min and max, and we are essentially skipping that in the accumulation of file min and max, right? And so we have a fix in to solve that problem on the iceberg side. What is unclear is why Trino writes are doing this, and why we're getting to this point where we have stats that are more than 4K. So then what narrows this down is you've got to have a column with values that are more than 4K. You've got to be filtering on columns that are potentially more than 4K. And there is, another dimension of it might only be Trino, it might be more widespread. So I don't think that there's much that we can do in iceberg besides completely ignoring stats before the 1.4 release, which is probably not something that we actually want to do.
So, but the underlying issue actually stems from the Parquet stats, because you either have a min value, or if it exceeds the 4 kilobyte, it doesn't get truncated, it gets dropped. Because in Parquet, the stats...
Right, but Parquet truncates the values before they get to the metrics converter.
They don't, actually. Like that's an option you can turn on, but it's not the default. And it's actually not in adherence with the iceberg spec, because it doesn't, like iceberg spec for the column stats doesn't allow for lower upper bound. It's only min and max value, which is why we actually drop the min or max as opposed to truncating it. So it just doesn't get included.
Okay, you and I should sync up on more details. In any case, there's nothing we can do on the iceberg side. And I wanted to make sure that everyone's okay with the solution here is, go rebuild your iceberg metadata and detect these files if you think you have this problem.
It's still a little bit unclear to me because like it's up to the writer to populate the like, for example, if you take the Parquet writer in this case, that's in iceberg, we take the metrics from the footer and we iterate it per row group. If we detect that a certain row group doesn't have metrics for the entire column, why don't we nullify the rest of the file?
That was the bug in iceberg that's been fixed. We did not detect that the row group was missing stats.
So,
Okay.
So this is a case where the row group has counts, but it doesn't have min-max.
Okay.
Ryan, when is this fixed?
This was fixed a few days ago.
Okay.
Yeah.
Because we run into a similar issue in the Trino. Because for like a floating type column, there's not a number. That was used as one, either min or max, I don't remember exactly. And the result is that we're skipping the whole row group. We're not actually.
Yeah, we've had solutions in for NaN values for a long time, but there could be an issue with Trino producing correct metadata around NaN values. But yeah, NaN values we also detect and like suppress. We can look into that separately.
Okay.
I just want to highlight that this issue exists, and we're still looking into the extent of like, does it only affect Trino? Does it affect other engines, etc.? But we think it's narrow enough that it's not something that we want to take like broad action on. All right. Next, I wanted to bring up the idea of defaulting to resolving FileIO. So there's a PR out there that goes and changes the default FileIO implementation for, I think, Hive and other base Metastore implementations to resolving FileIO rather than Hadoop FileIO. That's something that we may want to do eventually. My concern is that it is going to be a fairly significant behavior change. So I wanted to run this past people that are using the Hadoop, sorry, the Hive and other catalog implementations to see, like, is this something that anyone is interested in doing, or is this something that we should save until the V2 release, when we can, I think, make this probable breaking change. Like, it's a pretty big change to have the to have your IO implementation swapped out. So I'm a little wary of just making it on by default.
I'm worried about it for that reason. One, because you might have specific S3A configuration that you're using your IO and you don't want to switch to S3 FileIO. And the other is it's actually resolving FileIO is different than both of its delegates or all of its delegates, because its batching behavior is slightly different than any of the delegates would have. So you don't actually have the same as you would if you had S3 FileIO before, or if you had Hadoop FileIO before. It would be different in both cases.
Yeah, that's true. So is that something that would prevent us from doing this at like a 2.0 release?
No, I'm fine changing them. Well, you know me. I'm always just like, let's change all things and break whenever we can. So I think at 2.0, it's good.
Yeah, I think the biggest concern for anybody using S3A is that, like, if you're using your default credential provider chain, like the S3 FileIO would start working, but all the other configurations you potentially had for upload sizes, file sizes, you know, e-tags, things like that would just all of a sudden get dropped. And if you rely on any of those things, it could be pretty bad to untangle.
Yeah. At the same time, this is a good step forward towards removing the dependency on Hadoop. Okay. So we'll plan on going back and revisiting that for 2.0.
I think it's the right idea, just probably when we can tell everybody this is a huge change.
Yeah. All right. Then we've got discrepancies around null counts for lists, maps, and structs. So this is a fun one. Paco, is that you?
Yeah, that's me. I was looking into it today, and It's not a correctness issue, but it's still something I think that we want to address because we see some different ways of counting across the. Well, I think the current implementation of Parquet is not really correct because if you can see the example in the notebook that we have there. It counts like both for the nulls that are inside of an list and also when the list itself is null. I think that we should make a differentiation between those. And we also see like different results when you write as Parquet and as ORC. And actually, I think ORC is more correct in this case. But I think what we should do as a first step is just to make sure that we get some common definition around this in the spec, that everyone agrees to it. Then we can start looking at all the different implementation, just make sure that they adhere to the same behavior. Because also in PyIceberg, I was looking like, how should you write like the computer specs? And I think it's a good step just to do it, to maybe take like a step back and just to decide on this, and then do it across all the implementations.
Are there steps that we can take in the meantime? So like what we've done previously was basically say, okay, even though we don't have anything that takes advantage of array or map, stats, basically if it's in an array or it's in a map, we preserve what Parquet told us were the stats and the null counts and all that, but we don't have anything like a contains null, contains value, any of those sorts of predicates that you might want to run against a map or a list. We've contemplated doing that. So like a map contains key to push down, it would be a very reasonable thing to do. That wouldn't actually be affected by this, but you could say like, map key contains null field or something like that.
Ryan, are you suggesting like adding new metrics to this to address?
No, I'm suggesting the opposite. We've always kept the metrics around just in case, but now that we don't trust those metrics, maybe what we should do is remove them and stop for any nested field, just not keep the metrics. That would actually make planning easier because we would have less data that we're basically reading and writing at job planning time that doesn't get used. So I think that might be a good thing in any case. Just to say, like, if it's in a map or it's in an array, drop the stats entirely.
Yeah,
that way we're at least not persisting stats that we think are bad.
Yeah, I think the array situation is like tracking nulls in an array is largely meaningless because they're variable length arrays. So with the exception of maybe like a count null on an array, you don't really get a whole lot of information out of it. You just like get a total number of nulls from arbitrary length, arrays in values. It's almost meaningless. So I'd be in favor of dropping for arrays. I don't know about maps. And then there's the larger question of we're not tracking the top level field and null counts in the top level field, which may actually be useful. So you get a.element, but you don't get a, and whether or not a has nulls, and that could actually be pushed down.
I think that actually varies from file format to file format because in org, just the other day, I've seen that you can actually get some, like in Parquet, you only have, like if you have a struct, for example, you only have stats for the nested fields. But for org, you actually have for the struct itself, which are not always accurate, which was weird. Let me get a random like 0. And then like you have to check the nested field, but we actually persist those. That's kind of the bad problem. Like we take whatever we have and then we persist it.
Okay, so it sounds like no one's fighting to keep these null counts around, at least.
For array, definitely, I think I'm okay dropping it with array. I think I'd need to think about map. We probably want to keep them for struct though, right? Like nested structs, we would keep the stats for.
Yeah, I think that there's a difference between the struct level. We also need to figure out, I guess, structs. Structs, though, we at least know the number of rows in the table and the number of values in the struct. And so we can at least infer, you know, the number of nulls, I think.
Well, the one thing with the nulls, especially for the nested case, is just kind of like defining what behavior do we want. Because if you have a higher level reference that is null, you count that as a null for a lower level element when you do that. Because like the SQL behavior is like if you did a count, you know, null, you would actually get that count as null.
Yeah.
For stats, it may make sense not to do that.
The main problem with any of that, like the reason why I'm focusing on what should we not write is that that's a short-term fix, right? Like what do we not trust that we should not be writing into the files? It's a longer-term fix to either update Parquet to have a sensible way of tracking these things. I honestly don't know if we're gonna want to update Parquet or if we're gonna want to like do our own value counting as we're writing or things like that. So that's why I'm a bit more concerned about updating and saying like, hey, this is what it should be, and trying to get there, because I think like the lack of any the lack of any usage for these means we should just stop writing bad data and, you know, not worry about writing good data, I think.
So drop array and map and then figure out what we're going to do with structs.
Yeah.
Are you thinking we just stop doing nested structs initially and then figure it out?
Well, so at least for null counts, yeah, because then the only thing that we're, I guess you can express an is null, you know, a.b in a struct. That's probably okay though, to like not be able to push down is null or not null.
Yeah, I think the main thing is if we are aggregating the nulls in a way that doesn't make sense as you roll it up. But other than that, I would say leave them. I mean, if we're doing it correctly, we should just leave it. I think we just need to go back and look at structs a little more closely.
Yeah.
I think structs are much more important than lists and maps, so I think we should opt to kind of figure out some reasonable solution, because otherwise, I mean, I know a lot of people who have deeply nested data, and not being able to silently do min-max or whatever filters there, that would probably be not good.
Well, so this luckily doesn't affect the lower or upper bounds.
Just the
code? Yeah, this is just actually the value count is correct as well. This is just the null value count that we found discrepancies.
That makes it a little bit better.
Yeah. So it would just be like, hey, if this is a nested thing, just drop the null value count. If it's in a required chain, like if all levels of a struct are required up until that point, then we know that the null value count is still valid. Okay. So yeah, we'll focus on removing the nested values. That should make everything faster because we'll have fewer columns in these maps in general. And then we'll go forward with fixing up structs. Now, should we also drop min and max on arrays and maps because we don't use it at all?
I just checked Ryan, and they're not there because you sparked my interest there.
Oh, okay. So we already discard them.
Yeah.
We had min and max for like the elements.
Yeah, min and max for fields within an array. I thought that we did, but maybe we got rid of those. Okay, awesome. That solves that problem. Okay. Proposal: introduce delete vector to reduce write amplification.
Yeah, so this was a proposal by Renji originally. So for him it's now right midnight, so he asked me just to bring it up to the attention of the community sync, just to get some eyes on it. It's a similar approach to the positional deletes with some subtle changes there. For example, there's a one-to-one mapping to the file. So we just would like to invite you all to go through it and just to give Renji some feedback.
I think this is very similar to the approach used by Delta at the moment for their positional deletes. I think it's a fun idea. I don't know, Anton, how are you feeling about it?
So we've been discussing the idea of, like, first of all, we've been using deletion vectors for a couple of years, but they have been built while you kind of read the table. So in the vectorized pass, whenever you read a file, you would basically build a roaring bitmap of the positions, and we've been using that for years now. We've been thinking about maybe persisting those bitmaps on the right pass instead of positions. That's on the table, but I think my problem with this proposal that it's not really clear because it focuses on the right amplification, which is actually solved by the existing design. And what is not clear is like how this differentiates and what kind of improvements this actually gives to the compared to the design we currently have. And there are a couple of like points that we're looking for with positional deletes. First, how you can faster assign them. And second is like maybe drop in the local sort and whatnot. So technically, I think using the persistent bitmaps is probably something that we should consider, but it wasn't clear for me in this proposal how that's actually different from the existing design.
Yeah, I agree with that. It wasn't clear like what it was basically like, I think, hey, let's use bit vectors and store those, but we need a lot more information in order to do that. Like, do we maintain one bit vector per data file? If so, how do we track that? You know, track what data file the bit vector is against. Do we add requirements for rewriting the bit vector so that we are, if you have a deletion vector against a data file, do you have to rewrite that if you're deleting more rows from that data file? And if so, how do we do that, right? How do we carry that through so that when in the task writing deletes against a particular data file, you know that we can locate that deletion vector file easily to rewrite it? Because we're going to need to swap those and say, I'm replacing, you know, delete vector from snapshot 1 with delete vector for snapshot 2.
Yeah, and it's actually it would involve rewriting the metadata because like previously what you could do whenever you write right now, you actually add position delete files in a new manifest, but the data metadata is kept as is, so you're not rewriting this. And with this approach, if we were forced to keep a single deletion vector, then we have to modify that data metadata as well, which would probably make the commits much more complicated. So the solution that I was thinking back then is to have this kind of optional as a cache if you want. And then to speed up the planning as well. So for example, if there was some sort of partition level rolled up stats or whatever that would tell for this data file, you would have this set of position deletes that could mean that it basically you have the way to just write the position deletes as they are, but then also kind of offer something later on synchronously that will kind of cache that map in between the data file to the set of deleted positions. But again, I think it's worth discussing, but it wasn't clear from the current proposal.
So Anton, if this deletion vector is with the cache, we still need to check the position delete to see what the source of truth. I actually feel this proposal more like a materialized view on the delete, and like position delete is kind of is the source of truth. This is kind of materialized view. Okay, we compact everything into the delete vector.
So yeah, I think that that's the classic problem with many proposals to change iceberg metadata. It is, hey, here's something that we could do, but it's not clear how everything fits together, right? Hey, we could use deletion vectors, but how do we maintain them? How do we represent them in metadata? How do we, what are the rules around it? There's a lot missing here. And it seems like, yeah, we could, potentially speed up by using this as a caching mechanism, but then again, how do we make sure that we know how to cache and how to update it? So it just seems like there's a lot here that we're interested in delete vectors, but there's a lot here that is just unknown. I think it would be good to narrow at least some of the decisions that we're making on the addition of delete vectors. So one is, are we attempting to create a delete vector per data file and maintain it that way? Or are we looking to store large delete vectors in, say, puffin files that can contain more than one?
We should not be attempting to store it per file because the size of the rowing bitmap can get into megabytes if you basically need to persist a substantial number of records. So that is not something you can store in a general case in the metadata. I know that because I've tried.
Yeah. I mean, so I think that these would be files, right? Files just like we have the delete files today. We could have, like a third delete file format, which is a delete vector, right? So then there's the question: can we have multiple delete vectors against a single data file, or are we trying to make sure that we only have one? Can we store multiple delete vectors in a delete file? And if so, how do we track what the delete vectors apply to? I think some of those choices would be really good to have more data on. So things like, is it practical to have a delete vector per file? Is it a good idea or a bad idea, right? I don't know. Because it could be that it reduces the number of delete files against a data file because you know that you only have one delete vector.
I think if there was a globe like a partition, let's say partition scoped puffin file, as long as you can navigate quickly to like a particular bitmap within the puffin file. If that's not possible, then maybe persisting it like in a separate puffin file would be preferable. But at the same time, if like there is a design where you can store the offsets and then like the information that's required to quickly fetch a single bitmap out of a puffin file, then this opens up that opportunity to store more than once.
So we could do that. The nice thing about that is we can store all these bitmaps. In metadata, we'd probably go fetch the one puffin file, right? Or few puffin files for a particular partition, right? So we just see, oh, hey, there's a puffin file of bit vectors for this partition, attach that to every read task, and then the read tasks are responsible for reading the puffin footer and determining if there's a bit vector in there that needs to be applied. That's reasonable. What is a lot less clear is whether we would rewrite the entire puffin file of delete vectors every single write. Maybe that's reasonable if we are doing a bunch of deletes. Like I could see that actually working out because that's a good way to know exactly where the deletes are, right? It sort of skips this problem of, for a given data file, where is its delete vector?
I think it's something that's worth discussing. I can see benefits for both, and technically it shouldn't be that complicated or that expensive to do a bitwise operation to combine them at the read time as well. So I think this is exactly the question that this proposal has to kind of present answers to, because at this point it's not really clear. We're all for using a bitmap of deleted positions in the metadata somehow, but I think the proposal has to be more elaborate on how writes happen, how reads happen, whether it's one or whether you combine them, and whatnot.
Yeah.
Hey,
Okay.
y'all, we're rolling up on noon. Do we want to try one more, or do we think we'll have to scoot these to the next?
I want to briefly, because like the nanosecond timestamp, it does seem like we're close to next steps. So I'd say let's punt the others. For nanosecond timestamps, I think we basically understand the work that needs to be done. This would be a let's start getting readers and writers and some of the basics in, and then we can figure out how to add like a table level flag for enabling this. I think the biggest thing that's unclear here is how do engines like Spark that can't interact with nanosecond timestamps, what do we do? Do we try to, if you run a merge statement in Spark on a table with nanosecond timestamps, do we fail it? That's the main question, but we can at least start getting the readers and writers in. That's probably the next steps.
Okay, I'll follow up an email. Thanks.
Thank you. All right, thanks everyone. Good discussion today. Amogh, I'll follow up with you on the validation API for delete files. And I know that the partition stats spec is out there and could use some people looking